Hello class. Today we're going to talk about the quadratic formula, and we're going to get into some quadratic word problems that require the quadratic formula. So you learned it last year in Algebra 3-4. The quadratic formula, we use it to find a quadratic zeros, or also known as its roots or x-intercepts. So here I have a graph of two quadratics, and also please don't let the fact that this is a little sideways or askew bother you too much. I just stamped it badly. But here you see this function here. It's going up, and these points right here where it crosses the x-axis, those are our roots, zeros, or x-intercepts. All the same thing. I'll be using those words interchangeably. And here is the example of a downward-facing parabolas, zeros, roots, or x-intercepts. So the quadratic formula is this: if f of x equals ax squared plus bx plus c. So this is the general form that we're using of our quadratic functions. Then x is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So definitely write this down. You will definitely need it unless you want to memorize it. That's good too. So I guess we have no choice but just getting into it and doing the nitty-gritty. So here we have a quadratic function, and I want to find its zeros or roots or x-intercepts. So in order to do so, I need to solve for x. But notice that it's going to be hard to solve for x because I have an x squared term and an x term. If you were to take some time and try to solve for x yourself, it would be quite challenging. That is why we like the quadratic formula. We can just plug in our values, simplify, and we get our zeros. So first, let's define our a, b, and c, because notice we'll need our a, b, and c in here. So we have a equals, b equals, and c equals. A is the coefficient of our x squared term. In this case, it's 1. B is the coefficient of the x term. In this case, it's negative 12. And c is the coefficient of, well, c is the constant term, which is, this case, is 20. So now that I've defined my a, b, and c, I'm going to go ahead and plug it into the quadratic formula. So x equals negative b. Well, b is negative 12, so it's going to be negative 12. Be careful there. Plus or minus the square root of b squared, so 12 squared, or negative 12 squared, I'm sorry, minus 4 times a, 1 times c, which is 20. And you might ask yourselves, where did I get the 4? The 4 is in the formula right there. All divided by 2a, so 2 times 1. So now this mess looks a little ugly, doesn't it? So now this is the most challenging part of this, is the simplification process. And yes, you probably will want a calculator for this. The ones in your phone will do just fine. So how we're going to simplify this is we're going to simplify it just like we read a book. We're going to start from the top left, work our way right, and then the next line, do it like that. And it'll take a few steps to simplify it all the way through, but you'll see how we'll do it as we go along. So x equals, well, negative times negative 12 is going to give me a positive 12, plus or minus the square root of, now I like to do this part and then do this part. So negative 12 squared is going to be positive 144. Now be careful on your calculators, depending on how your calculator is, and I think they're just different depending on what kind of phone you have or what kind of app you're using. Be careful how you type it in, because remember that when we square something, we should always get a positive value. So if some of them read this negative as separate outside, it squares it and then multiplies it by the negative. So if you square something and you get a negative value, something went wrong there. Okay, so just be careful. Okay, so negative 12 squared is 144. And then I like to multiply these all together at once. So negative 4 times 1 is negative 4. And then so negative 4 times 20 is negative 80. So this is going to be minus 80. So I just did, so in here, in the discriminant, that's what we call, what's the square root part. Negative 12 squared is 144. And then negative 4 times 1 times 20 is negative 80. That's how I got those two numbers. And then all divided by 2 times 1, which is just 2. Well, this is looking a lot better already, doesn't it? We can continue simplifying under the square root here, so let's continue doing that. So x equals 12 plus or minus the square root of 144 minus 80 is going to be 64 divided by 2. Now, sometimes, and that won't be the case today, we won't have a perfect square under the square root, which means we would generally stop right here. I mean, in this case, we could divide out at 2 if we want to do the extra work. But whenever we have a perfect square under the square root, we want to keep going and keep simplifying, okay? So I'm just going to draw a little arrow here and go back up to the top. So let's take the square root of 64. And the square root of 64 is 8. So x equals 12 plus or minus 8 divided by 2. Now make sure after you take your square root, make sure you get rid of your square root symbol. Make sure you get rid of the radical. You don't want to keep it there because it just means if you keep it there, it means you still need to take the square root, which we already did. Okay. So now you see that we have 12 plus or minus 8 divided by 2. This plus or minus means that one function or one equation is going to be 12 plus 8 divided by 2, and the other one's going to be 12 minus 8 divided by 2. So we're actually at this point, we're going to split this equation up into two separate equations because we're going to get two answers with this, and we normally always do. The only exception is if we have a 0 right here. So we're going to have x equals 12 plus 8 divided by 2. And we also have 12, or x equals 12 minus 8 divided by 2. So again, I just split it up. And now we just want to simplify. So let's simplify the top and divide by the bottom here. So for this one, 12 plus 8 is 20. 20 divided by 2 is 10. And here, 12 minus 8 is 4. 4 divided by 2 is 2. So our answers here are x equals 10 and x equals 2. So basically, what does that mean? Well, that means if I were to plug in 10 back into for x, I would get 0. And if I would plug in 2 back in for x, I would get 0. Now, what does that mean graphically, though? That means that on my x-intercept, or on my x-axis, if I were to draw, I know I have my stamp, I don't know why I'm doing this, but if I have my axis here, this is my x, this is my y, that means at 2 and 10, that's where my function crosses the x-axis. So that's what that would mean, and that should be right. Oh, you get the point. Okay, awesome. Let's do a few more examples, and in fact, we're going to do quite a few examples on this, just to kind of get it down. So now we have f of x equals x squared plus 2x minus 35. Well, again, let's first start by defining our a, b, and c. And, you know, I'm going to go ahead and rewrite the quadratic formula up here for us, just so we have it in view. Okay. Our a is the coefficient of the x squared term, so in this case it's 1. B is the coefficient of the x term, so it's 2. And c is the coefficient of, or well, it's the constant, it's negative 35. Okay. So now let's plug it into the quadratic formula here. x equals negative b, so negative 2, plus or minus the square root of 2 squared minus 4, remember 4 is in the formula, 4ac, so 4 times 1. Wait. You know, let's skip this one. I think, oh no, never mind. Minus 35. I thought I was doing something wrong for a second. I thought I made a bad equation for us. Okay. So I goofed. I did goof. Okay. Well, that's okay. Let's start over. Okay. So x equals negative 2 plus or minus square root of 2 squared minus 4 times a, which is 1. That's what I forgot. And c, which is negative 35. I apologize for that. All divided by 2a. So 2 times 1. Okay. So now let's go ahead and simplify this, just like we read a book. Top left to right, and then bottom left to right. So x equals negative 2. There's nothing to simplify out here. Plus or minus the square root of, now I like to do this part first. 2 squared is 4. And then I like to do this part all at once. So negative 4 times 1 is negative 4. Negative 4 times negative 35 would be positive 140. All divided by 2 times 1 is 2, and it's looking a lot better now. So continue simplifying under the radical here. We're going to get x squared equals negative 2 plus or minus square root of 144 divided by 2. I just added 140 and 4 to get 144. And now we can take the square root of 144, because that is a perfect square, and the square root is 12. So we're going to have x equals negative 2 plus or minus 12 divided by 2. Now, this is when we get to the point where we want to split it into two equations, after we take the square root. So, x equals negative 2 plus 12 divided by 2. And the other one is going to be x equals negative 2 minus 12 divided by 2. And then we just simplify the top, divide by the bottom. So negative 2 times 12, or sorry, times. Negative 2 plus 12 is 10, divided by 2 is 5. And then negative 2 minus 12 is negative 14, divided by 2 is negative 7. And that's it. Got our two answers. All right, let's do one more of these before we move on to the word problems. Again, we're going to start off by defining our a, b, and c. And let's see, our a, ooh, look, in this case our a is negative 1. There's a negative out front. And b is going to be 11, and c is going to be negative 30. Looking at this, what direction does this quadratic face? Just thinking about lessons that we've had before. This one is going to be facing down, right? Because there's a negative out front. Just cool little observation, I suppose. So this would have a maximum, wouldn't it? Yeah, pretty cool stuff. Okay. Let's plug this into the quadratic formula. So x equals negative b, so negative 11, plus or minus, and don't worry, on your worksheet I'm putting the quadratic formula there so you'll have it. Plus or minus square root of b squared, so 11 squared, minus 4ac, so minus 4 times a, which is negative 1, times c, which is negative 30. Wait, what am I? all divided by 2a. So 2 times negative 1. Okay. Oop. Negative right there. Okay. So x equals, now let's simplify just like read a book again. So negative 11 plus or minus the square root of 11 squared is, I believe, 121. Let me just double check. Yes, it's 121. And then negative 4 times 1, or sorry, negative 4 times negative 1 is positive 4. Positive 4 times negative 30 is negative 120. All divided by 2 times negative 1. So that's negative 2. We'll continue simplifying under the square root here. So x equals negative 11 plus or minus square root of, well, 121 minus 120 is just 1, divided by negative 2. Now we take the square root of 1, that's just 1, and also notice that these negatives cancel each other out, right? If we have a negative on top, negative on bottom, they just can both become positive. So x is equal to positive 11 plus or minus 1 divided by positive 2. And this is where we will split up our equation into 2. One will be x equals 11 plus 1 divided by 2. And the other one's going to be x equals 11 minus 1 divided by 2. Well, 11 plus 1 is 12. 12 divided by 2 is 6. And 11 minus 1 is 10. Divided by 2 is just 5. And there you have it. Our answers are 6 and 5. So that's the quadratic formula. That's how we use it in practice, mathematically. Well, I should say that's how we use it mathematically. But how do we use it in practice with real-life situations? So let's move on to the quadratic word problems. Okay, so let me read this first, and then I'll kind of give some explanation about it. So the profit made by selling X number of croissants can be modeled by P of X equals negative X squared plus 17X minus 30 for X is greater than or equal to 2 but less than or equal to 15. How many croissants must be sold to make at least $12 in profit? Now, a lot of times we can model profit. Well, depending on your model. Sometimes we can model profit by using quadratics, because a lot of times there's kind of a sweet spot we want to hit in order to maximize profit. Remember doing that from last lesson. So this is a negative quadratic. So it's going to look something like, now I don't know where the exact zeros are yet, but so forgive me, but it's going to look something like this, right? So the y is profit, x is number of croissants. So as we make more and more croissants, we make more and more profit until we hit a point where when we actually start selling more croissants, the profit actually goes down. And that could be a function of cost, of product cost, right? Or labor cost, anything like that. But if we have a function like this and we want to make at least $12 profit, well, that's some y value, isn't it? So that's going to be a y value that looks like this. So our answer, when we want to make at least that much money, is going to be from here to here. It's going to be this whole area, right? So our answer is going to look like x is less than or x is less than or equal to some value, and x is greater than or equal to some value, right? I could say x1 and x2 because those are going to be actual values. So that's kind of how we're doing this. Now, let's see how we're going to set this up. Well, first off, I just want to point out this part. The function can be modeled by this equation for x is greater than or equal to 2 but less than or equal to 15. You don't, with what we're doing, we don't need this information. This information is just saying this model only works between these two values. Because think, this function goes on forever, right? And like if I keep going down here, I can't sell negative croissants, can I? No, so the function falls apart there. So this is just saying where the function makes sense for us, okay? But don't fret over this, okay? This is kind of extra information that we don't really need, okay? So what we want to do is we want to know when this function will equal $12, because that would give us our 2 points, right? And then everything in the middle would be the profit. So how about we do this? How about we set our function, which is negative x squared plus 17x minus 30, how about we set it equal to 12 and solve for x? Well, that's a great idea. In fact, that's exactly what we want to do. But what we need to do first is we want to move this 12 over because we want to know when x equals 0, or else we're going to get funky answers. So once we have set it up, let's move everything off to one side, which means I'm going to now subtract 12, which is 0 equals negative x squared plus 17x. Negative 30 minus 12 is negative 42. And remember, when we subtract, we can only subtract like terms. So we're subtracting the constant from the constant. So now this is our new function. So this is what we're going to use to define our a, b, and c. So a is equal to negative 1, b is equal to 17, and c is equal to negative 42. Now this is what we're going to plug into the quadratic formula. Okay? So again, we set our function equal to the value, and then we moved everything over to one side, and then these are the numbers we're setting up. Okay? And we're going to want to do that with all of these word problems. So let's get started with the quadratic formula here. What color should I use? I'll use green. God, I got so many options. Okay. So x equals negative b, so negative 17 plus or minus the square root of 17 squared minus 4, remember the 4 is in the formula, times a, negative 1, times c, negative 42, all divided by 2 times a, so 2 times negative 1. Okay, so now let's simplify, again, like we read a book. So x equals, there's nothing to simplify here, negative 17 plus or minus square root of, oh boy, I'll need to get my calculator out for this because I don't have 17 squared memorized. 289. That doesn't even sound familiar to me. Okay, 289, and then I'm going to use a calculator for this just because I don't want to mess up my mental math. Negative 4 times negative 1 times negative 42 is minus 168 divided by 2 times negative 1 is negative 2. Now continue simplifying under the square root. X equals negative 17 plus or minus the square root of, and what is it? Again, I don't want to mess it up. 121 divided by negative 2. We know the square root of 121. Well, I do. You can plug it into your calculator if you don't. I don't know. I just have these memorized. Don't feel bad if you don't have them memorized. But square root of 121 is just 11. We ran into that earlier in an earlier problem. So, oh, and we can also drop these negatives, right? So we can say x is equal to 17 plus or minus 11 divided by 2. And then we can split it up into two equations. So one is going to be x equals 17 plus 11 divided by 2. The other one is going to be x equals 17 minus 11 divided by 2. 17 plus 11 is 28, divided by 2 is 14. 17 minus 11 is 6, divided by 2 is 3. So, one of our points here is 3, and the other point is 14. So that means in between those 2 points is where we'll be making profit. So x has to be less, well, has to be less than 3, or no, sorry, has to be less than 14, but greater than 3. And you can argue if it should be less than or equal to or greater than or equal to. Profit technically, though, does mean making money, but can you have a $0 profit? I don't know. That's arguable. I think that's just semantics at that point, just arguing definitions. But if you want to do greater than or equal to, I won't bug you. In fact, I did it up here myself. So, okay, boy, was that a problem. Let's do another one. The longest part of these is really just the quadratic formula, just the simplifying it. Okay. So a lemonade stand can model their profit made by selling X number of lemonades by using the function p of x for x's between 1 and 20. How many lemonades must be sold to make at least $18 profit? So again, what I'm going to want to do is I'm going to want to take my function, negative x squared plus 21x minus 20, and set it equal to how much I'm trying to make at least. That's 18. And remember, I can ignore this. This is just extra information given to me. So let's see here. I want to move everything over to one side. Remember, that's my first step. Move everything off to one side. So I'm going to subtract 18 from both sides. And remember, I can only combine same common terms. Like terms? Like terms. There we go. So this is going to be 0 equals negative x squared plus 21x, and then negative 20 minus 18, that's negative 38. And then these are the numbers that I'm going to use to plug into the quadratic formula. So again, I'll define my a, b, and c. A is negative 1, b is 21, and c is negative 38. And let's get to it. So x equals negative b, so negative 21, plus or minus the square root of 21 squared, that one I definitely don't have memorized, minus 4 times a, which is negative 1, times c, which in this case is negative 38, all divided by 2a, so 2 times negative 1. Boy, these things are really ugly when you first plug everything in, aren't they? But they do get a lot nicer. So we're going to simplify this. Negative 21 plus or minus the square root of 21 squared, and yeah, I'm using my calculator for this one, 21 squared, 441. Huh. That's okay. I'll tell you why that's interesting in a second. Oh, I guess so. Okay. Let's see here. So negative 4 times negative 1 is positive 4. Positive 4 times negative 38 is negative 152. All divided by 2 times negative 1 is negative 2. Continue simplifying. Negative 21 plus or minus the square root of 441 divided, or sorry, minus 152 is 289. All divided by negative 2. And I believe from our last problem, 289 was the square of 17. So the square root of 289 is 17. And we can also drop these negatives because we have matching negatives. So 21 plus or minus 17 divided by 2. And then now we'll split our function into two, our equation into two equations. So x equals 21 plus 17 divided by 2. X equals 21 minus 17 divided by 2. And then, let's see, 21 plus 17 is what, 38? Yes, 38 divided by 2, 19. And then 21 minus 17 is 4. 4 divided by 2 is 2. So in this case, how many lemonades do we need to make a profit? Well, that's going to be between 2 lemonades and 19 lemonades. So our X, which stands for lemonades, has to be greater than 2, but less than 19. And that's it. Also, what I was going to say, I found so interesting is I guess I never realized it, but I'm going to have to do some research here. So 12 squared is 144. And you switch these, the 2 and the 1. 21 squared is 441. Ooh. Terrifying. Okay, that's it. So that's it. Have a good day, y'all, and I will. Well, I guess we'll reconvene next time. Bye.